And welcome back, everybody. We're here with some antiderivative rules. So some things I want to talk about. And these rules should look eerily familiar because these are the same rules that we have for derivatives. And that hopefully makes sense because an antiderivative is the opposite of a derivative. And one of them is you can pull out a constant. So if you have, for example, the integral of some constant times f of x, or the antiderivative of a constant times f of x, you bring the constant in front and then take the derivative or the antiderivative of f of x and continue. So if you have to integrate, for example, negative 3 times cosine of x. Well, you pull the negative 3 in front and find the antiderivative of cosine of x. So that just becomes negative 3, derivative of sine is cosine, so negative 3 sine of x plus a constant c. And again, in my head, when I take a derivative of this, derivative of negative 3 sine x is negative 3 cosine x, and that's what we start with. Great. Okay, now also you can split them up over addition or subtraction. So if you have the integral of f of x plus or minus g of x, you can just take the antiderivative of those separately. So you take the antiderivative of f of x, dx, and we always write the dx. I know it's a little weird. We'll get used to that. And then we take the antiderivative of g of x. So, and that should be a plus or minus 2 also. So just for an example, if we have to take the antiderivative of, say, 4 plus 2x, well, we just separate this out, right? So we take the antiderivative of 4, we take the antiderivative of 2x, and then we just add a plus c. You just need 1 plus c in the end. Okay, derivative of 4x is 4, derivative of x squared is 2x, so it's 4x plus x squared. Okay, now, one thing that you cannot do, and then we'll get some examples in a minute, and you'll see why very immediately. No, you cannot do this with multiplication or division. And we'll deal with some of those problems later in some extent, but just like the product rule and the quotient rule, it's more complicated, right? If you have to take the antiderivative of two functions multiplied together, so f of x times g of x, is that equal to the integral of f of x times the integral of g of x? And hopefully you recognize the answer here is no. You can see a really quick example, right? Is the antiderivative of 2x cosine x, does that equal x squared times sine of x plus c? And the answer is, of course not, because you have to use the product rule in this, right? You would do the product rule and you would get a bunch of terms that would not just be 2x cosine x. So this does not work. You're not allowed to do this. Okay, so I just wanted to be clear. You can do this with addition, you can do a subtraction, you can pull out constants. You can't do it if functions are multiplied or divided. Okay, so let's look at a few examples, right? So suppose I ask you to take the antiderivative of y to the 1/2 minus 9y to the 5/4 plus 4 minus cosine of y. Okay, so let's just go part by part. Just do each part separately. So when we do the antiderivative of y to the 1/2, so that'll be y to the 3/2, and we put a reciprocal in front. For the this is a really bad 5, sorry. For the next one, let's leave the minus 9 in front. So if I do 5/4 and I add 1 to that, so I add 4 over 4, that's 1, I'm going to get y to the 9/4, and then balance with a reciprocal 4 9s in front. Those will cancel. And then antiderivative of 4 is 4y minus, derivative of sine cosine, we've been over that a bunch of times today, and then the plus c. No real way to clean this up other than just kind of canceling those 9s there. So just go part by part, and that's what these rules allow us to do, is just integrate each part one at a time. Okay, let's look at a couple other examples here. Say we take the antiderivative of 3 over x to the 4 plus 1 divided by cosine squared of x. Don't freak out about the cosine squared of x yet. Let's just rewrite this. So let's rewrite this as antiderivative of 3x to the negative 4 plus secant squared x. Okay, now what function then has an antiderivative of x to the negative 4. Okay, so I'm going to add by 1. That's x to the negative 3. Negative 4 plus 1 is negative 3. Divide by the negative 3. What function has a derivative of secant squared? You rack your brain. Do you think about those trig derivatives you memorized? It's tangent. Yeah. So it's just tangent. So these cancel, so this is just negative x to the negative 3, which you could rewrite if you want, plus tangent x plus c. So that's how you approach the problem. Let's look at one more type problem here. What if you have to find the antiderivative of, say, x cubed minus x minus 2 over x. Now, what I want to remind you guys to do is to rewrite this. Don't get scared by the fraction. Break this up into x cubed over x minus x over x minus 2 over x. Because now you're like, oh, this is just the antiderivative of x squared minus 1 minus, and this is just 2 times 1 over x. And then you see that this problem has become a lot more straightforward. The antiderivative of x squared is x cubed over 3. The derivative of x is 1, so there's a minus x. And then the antiderivative of 1 over x is ln absolute value x plus c. Okay, so that's how you're going to approach these problems with antiderivatives. If you have a polynomial or something that looks like it, just split it up. Do each part separately, leave the constants in front. Okay, thanks for watching, and I'll see you guys soon.